Imagine being told to build a civilization using nothing but rocks, dirt, and fire. No electricity, no thermometers, no chemistry textbooks. Yet somehow, thousands of years ago, humans learned to create temperatures hotter than 1200 degrees Celsius, hot enough to pull metal out of stone. Think about that for a moment. A metal sword, a metal plow, even the technology that eventually led to cars, computers, and spacecraft all began with one incredible discovery. Certain rocks could be transformed by heat. But how did ancient people achieve such extreme temperatures without modern technology? And how did they turn ordinary stones into the metals that changed the world forever? This is the story of how ancient humans mastered fire and unlocked the age of metal. Imagine you're an ancient human sitting around a campfire about 10,000 years ago. Life is simple. Fire cooks your food, keeps predators away, and gives everyone a cozy place to tell terrible jokes. But one day, something strange happens. A colorful rock accidentally ends up near the hottest part of the fire. Hours later, the rock doesn't look quite the same. Instead of staying a boring stone, part of it has transformed into a shiny metallic substance. At first, nobody knows what's happening. Did the fire eat the rock? Did the spirits perform magic? Or did someone accidentally invent a completely new technology? Long before anyone understood chemistry, ancient people began noticing that certain rocks behave differently when heated. Some cracked, some changed color, and a few released tiny amounts of metal hidden inside. Even more surprising, naturally occurring metals like gold and copper could be hammered into shapes without breaking. Suddenly, rocks were no longer just rocks. They were potential tools, ornaments, and maybe even sources of power. Without realizing it, these curious experimenters were taking the first steps into metallurgy, the science of turning stone into metal. And it all began with a simple fire and a very lucky accident. Discovering metal inside rocks was exciting. Actually getting that metal out was a completely different problem. Ancient humans quickly realized that smashing a copper-colored rock with another rock was not an effective manufacturing strategy. So they began experimenting. Lots of experimenting. They collected green and blue copper ores, crushed them into smaller pieces, and threw them into hotter and hotter fires. Eventually, they discovered something remarkable. If copper ore was heated with charcoal inside a confined space, the rock would release pure copper. For the first time in history, humans weren't simply finding metal. They were creating it. This was the birth of smelting. The process wasn't easy. Workers spent hours digging ore, breaking stones, feeding furnaces, and watching fires like very nervous chefs waiting for a complicated recipe to finish. But the rewards were enormous. Copper could be shaped into tools, jewelry, needles, fish hooks, and weapons. Soon, certain people became specialists. The world's first metalworkers emerged. Their workshops filled with smoke, glowing embers, and mysterious knowledge that most people didn't understand. The Copper Age had begun, and humanity was taking its first major step from the Stone Age toward a world built from metal. By now, ancient metalworkers had a problem. Copper was useful, but extracting more metal required something they desperately lacked: more heat. A normal campfire can get pretty hot. Hot enough to cook dinner, hot enough to accidentally burn dinner, but not always hot enough to efficiently smelt large amounts of metal. So ancient humans did what humans always do when faced with a challenge. They started engineering solutions. One clever idea changed everything, forcing more air into the fire. At first, people waved branches or blew through tubes. which worked for about 30 seconds before everyone got dizzy. Then came the bellows. These simple air pumps pushed oxygen directly into the flames, and the fire responded like it had just consumed 3 cups of coffee. Temperatures soared. Furnaces glowed brighter. More ore could be processed. More metal could be produced. Soon, metalworkers began building specialized furnaces from clay and stone, carefully designed to trap heat and control airflow. Without understanding modern physics or chemistry, they had discovered one of industry's most important secrets. A hotter fire isn't just about more fuel. It's about more oxygen. Thanks to this breakthrough, ancient furnaces could reach temperatures above 1,000 degrees Celsius, opening the door to larger-scale metal production and even more advanced metals in the future. Humanity wasn't just using fire anymore. It was learning how to command it.
Just when ancient metalworkers thought they had mastered copper, they discovered something surprising. Copper had a flaw. It was soft. A copper knife could cut things, but after enough use, it might start looking more like an expensive spoon. Humans needed something stronger. The solution arrived through experimentation, trade, and probably a few happy accidents. At some point, metalworkers began mixing copper with another metal called tin. The result was bronze, and bronze was a game changer. It was harder, stronger, and more durable than pure copper. Suddenly, tools stayed sharp longer. Weapons became more effective. Farmers could work tougher soil. Builders could shape stronger equipment. But there was a catch. Copper and tin were rarely found in the same place. That meant people had to travel, trade, and connect with distant communities. Soon, trade routes stretched across deserts, mountains, and seas. Entire civilizations became linked by the demand for bronze. In a way, bronze wasn't just a metal. It was an ancient technology platform. It connected miners, traders, craftsmen, soldiers, and kings. The Bronze Age had begun, and humanity's first great metal revolution was underway. Bronze was amazing. Stronger than copper, more durable, and powerful enough to help build entire civilizations. But eventually, humanity found something even better. Iron. There was just one problem. Iron did not want to cooperate. Unlike copper, iron is rarely found in pure form. It is locked tightly inside iron ore, and freeing it requires much higher temperatures. Ancient metalworkers quickly learned that working with iron was like trying to negotiate with a very stubborn rock. Their furnaces couldn't fully melt iron. Instead, they produced a strange, spongy mass called a bloom. And that bloom was full of impurities. So the real work began. Blacksmiths heated the bloom until it glowed bright orange, then hammered it over and over again. And again, and again. Imagine spending hours hitting a rock just to turn it into a useful tool. Somewhere in history, the first blacksmith probably had very strong arms. But the effort was worth it. Iron was abundant, much more abundant than tin. Soon, iron tools spread across farms, workshops, and battlefields. Axes cut deeper, plows dug farther, weapons became stronger. Entire societies became more productive. Iron didn't just replace bronze. It transformed civilization itself. For the first time, one of humanity's most powerful materials was available almost everywhere. And the Iron Age was born. By now, ancient metalworkers were doing something remarkable. They had learned to control heat, transform ores into metals, and forge powerful tools. There was just one funny detail. They had no idea what atoms were. No chemistry, no thermodynamics, no periodic table hanging on the workshop wall. Yet somehow they kept getting better. How? Observation. Ancient metalworkers became masters of watching. They watched the color of flames. They watched the color of glowing metal. A dull red glow meant one thing. Bright orange meant another. White hot metal meant everyone should probably stand back. Generation after generation, knowledge was passed from master to apprentice, not through textbooks, but through experience. That color is too cold. That spark means something is wrong. That sound means keep hammering. Slowly, workshops became experimental laboratories. Every success was remembered. Every mistake became a lesson. Some smiths even learned how adding carbon to iron could create an even stronger material, steel. They couldn't explain the chemistry, but they could see the results. In many ways, ancient metallurgists were scientists before science existed. Armed with nothing more than fire, observation, and endless curiosity, they unlocked secrets that would shape human civilization for thousands of years. It started with a simple campfire, a few curious humans, and some unusual rocks. Yet those humble experiments would eventually change the entire planet. Over thousands of years, furnaces became larger, bellows became more powerful, workshops became factories. The techniques developed by ancient metalworkers were refined generation after generation. Bronze Age furnaces evolved into iron foundries. Iron foundries evolved into blast furnaces. And blast furnaces helped launch the Industrial Revolution. Suddenly, humanity could produce metal on a scale ancient smiths could never have imagined. Railways crossed continents. Bridges spanned rivers. Ships connected the world. Skyscrapers reached into the clouds. All built upon lessons first learned beside ancient fires. Even today, modern steel plants still rely on the same basic idea discovered thousands of years ago. Use heat to transform raw materials into something more useful. The smartphone in your pocket, the car on the road, the satellites orbiting Earth, every one of them depends on metals shaped by high temperatures. In a way, modern civilization is simply the latest chapter in a very old story. A story that began when our ancestors looked into a fire and wondered, what else can this do? And that question continues to shape the world even today.